So we saw about the need for QoS, and then we saw two flavors of QoS, two flavors of queuing method. One is fair queue. Fair queue is dynamic queue, no classification needed. As the flow comes, bandwidth will be provided. If there are 10 flows, then the available bandwidth will be equally divided and given to each flow. How flow is identified? Flow is identified with source IP, destination IP, source port number, etc. So if this differs, then it is different flow. Same source, same destination, same port number, then it is one flow. How many million traffic may come? It is only one flow. So that is fair queue. But the problem with fair queue is bandwidths are equally given. What if one of the flow needs more bandwidth, the other one needs very small amount? Then giving equally is not good. For example, these voice traffics are always very tiny, but they are time sensitive. So they need proper reservation so that they won't get disturbed. They will not stop. They will not be lost. So weighted fair queue was introduced, where we need to now discuss on that, weights. We spoke about weights a little bit, but we are going to go deeper today. To provide weightage, we have bits to mark and define the weight. When you say I'm doing layer 2 QoS, on the trunk link, we know that .1 queue protocol will come. This .1 queue tagging has got 3-bit reservation called class of service bit, COS bit, class of service, just 3-bit, 3-bit. With this 3-bit, you get 8 different options. Like this is the least weightage, and this is the most highest weight marking. So when we have traffic with 000, what does it mean? It means that there is no QoS. There is no QoS. This is default. In that case, because no weightage, it is considered as first in, first out. See, on every port of the switch or a router, this physical port has got a buffer. We call it as hardware queue. Anything that enters into this hardware queue will leave first. CPU is here. After processing, anything that goes first into this queue will be kept in the data plane and pushed out first. Now, when you have weights marked, the one with a high weight gets into this one first. So there's going to be a multiple queues created, soft queues. This is soft queues. This is hardware queue, I told you. This hardware queue, you have nothing to do. You can't do anything. That's a buffer. That's a hardware queue. Comes along with a chipset. This is what we create. So we create queues, and this queue has got the high weightage, this has got the next high weightage, and so on. So whenever traffic is in this, it will be given high priority to enter, and then this, and then this, and then this. Class-based weighted FAQ. So weights determines which traffic goes inside the hardware queue first. That is weighted FAQ. But again, there is some problem here. What is that? If this traffic is too much, the others all need to keep waiting. Because the one with the high weightage is given priority. If only there is no data in that high weightage, the others are given subsequently. So anyway, I'm coming back to this one. I don't want to get into the queue types again. We will talk about that later. Now, this weights are to differentiate the priority level for traffics. Only 3 bits. And again, in layer 2, you cannot use these two. These two are only for management. Internally, switches and routers will use these two. These are reserved, like 6 and 7. Marking CoS 6 and CoS 7 is recommended not to use. But if you want to use, you may use it. You have an option to do that, but already these devices are configured to use those markings for management, internal managements like STP, spanning tree protocol. They are more important than any other traffics. If you don't have spanning tree, then there is going to be a loop. So the most important management traffic like spanning tree need to be highly prioritized. For that, we have 6 and 7 reserved. So usually for voice, it starts from here. Voice is the user traffic, the most important user traffic. So from 5 only it starts. For voice, for video, goes like that. Alright, this is no priority, no marking. This is first in, first out. So you can go down from 5 to 1. 5 is the high weightage compared to 4. 4 is high weight compared to 3, and so on. Now, in layer 3 also, in IP header, we do have 3-bit reservation. Why? So that the preference, the weight, that priority that you give in layer 2 will also be maintained in layer 3. So, if you mark layer 2 with CoS 5, you can have ToS 5 on the router, so that the treatment is same both on layer 3 domain and layer 2 domain. Type of service, we call it as type of service. 3-bit in layer 3 header, type of service. So in layer 3, if you want to maintain the same priority level, then you may use ToS. But layer 3 also got more bits. If you wish to use that, then we call that as DSCP, Differentiated Service Code Point. DSCP. This DSCP is 6-bit. I'm giving this 3 different colors. There is a reason behind it. We'll come to know in a few minutes. So the 6 bits are there. Now you can have up to 64 different combinations, 64 different markings, not just 5, not just 0 to 5 like you saw in TOS and COS. 6 and 7 are reserved, I told you. It means recommended not to use. Here you have only few prioritization level, only 5, 0 to 5. But in DSCP you got more bits, then more level, more granular you can do. DSCP, Differentiated Service Code Point. Now from where this word comes, differentiated service. Why it is called as differentiated service? Now, in general, QoS is of 3 types. One is FIFO, you know that, first in, first out. First in, first out. The second one is INSERV. Is nothing but integrated service. And then DIFSERV. This DIFSERV is what you see here, differentiated service. Integrated service, differentiated service. What does that mean? Integrated service is end-to-end. Differentiated service is hop-by-hop QoS. Integrated service is end-to-end QoS. Differentiated service is hop-by-hop QoS. Hop-by-hop. Integrated service and differentiated service. What exactly it means end-to-end? This is your organization, this is your autonomous system. You got many routers, and this is where the traffic enters from left. The traffic leaves your organization. Let's say you have 2 ISPs. You got many routers and switches and much more. I don't want to make a big picture. You know it. So you will have many switches, many routers in your organization. They all makes one autonomous system. As the traffic enters, you set some priority so that within your organization, for that traffic, same level of treatment will be given. Now, if you do that like this, what you form a unique tunnel for each protocol. And then you pass the traffic to go inside. We call that as end-to-end INSERV. But the problem in this is you are reserving bandwidths. Hard code it. This tunnel is only given to that traffic. Even when the traffic is not there, the tunnel is there occupying the bandwidth. And you are not giving to others who are in need. You are not allowed to give because you go for in-serve. In-serve is end-to-end reservation. Now the traffic is entering here, but the reservation is done on all these routers where no one else can use that bandwidth. Though the traffic is here, why that reservation is done here? This is like the president is landing in the airport, but you block the entire city road. He has just landed in airport. Why are you blocking the whole city? That is not correct. As he proceeds from airport, you can block as he close to a road. Okay, block that road like 2 minutes before. So on. That is good. Instead of blocking end to end and waiting for the vehicles to pass through. So, in-serve is not good, end-to-end is not good. As the traffic enters the router, that router will decide what to do. And then once the traffic leaves, done, finish, over. Then this router will need to worry about. Then the switch need to worry about. So, hop by hop is differentiated service. Every hop will decide how I'll treat this traffic as the traffic enters. Every hop will decide the QoS. Whereas in the in-serve, the head-end router and tail-end router only decides. And all the middle router has to follow the instruction and reserve the bandwidth, keep waiting. You might have heard about some sadist chief ministers and prime ministers in the past. When he or she starts from home, the entire road, the entire beach road, entire road will be blocked till that, what do we call it as? Paralamandram. Whatever. They block the entire street, entire road, that entire city will be stunned, freezed. That madam is still wearing her shoes, but the people are under sun for half an hour. That is in-serve, not good. Diff serve is hop by hop. Even in QoS, diff serve is good, not in-serve. Okay, so now we need to next focus on this DSCP, Differentiated Service Code Point. Differentiated Service Code Point is something that we need to really focus, because many will have a lot of question on this particular thing if they don't learn during the learning hours. Future they will have a lot of questions. I told you there are 6 bits and I gave different color for a reason. And then one more bit. The reason why I'm giving this color is this. You know that CoS or ToS, it is 3-bit. That will match in this. Sorry. So that to match, you have this 3-bit. And then to go more granular, you have this 2-bit. And this 0, this is always 0. You need to remember this. This bit is always 0. And let's say you have 1, 1, 0, 1, 0, 0. How you need to convert this in a readable format? We have a term called assured forwarding. What is assured forwarding and what is best effort? Best effort is all zeros. That is best effort. Assured forwarding is this. This is what assured forwarding marking. Now, what is the value of this one? 6. What is the value of this one? Please try answering. This is 6. What is the value of this one? We'll say 4, right? You don't know how?
4.
What will be the value of this one?
4.
Okay, 4. That is what everyone will do, but they will not see what they want to see. The reason is this one is always 0 and keep this one separate. Don't calculate. So you see this only. It is 2. This is how it need to be read. Okay, AF62. Now I'm going to bring one table called table of DSCP drop precedence. Then I'll explain. Oh no. Now you see this is AF11. First let us learn how to read this, then we'll talk about the drop, low, medium, high. Now this is AF11. How AF11? As I said, you need to see this separate, these two separate, and this ignore. Value of this is 1. 1. Assured forwarding 11. Now let's see this one. 2, 3. AF23. Yeah, AF23. So if you don't know this, what people do is they calculate like this. This is 2, this is 4, and this is 16. 16 plus 4, 20, 22 they will say. It is not correct. Not matching, right? 22 is not correct. This is AF23. Sometimes, they do like that. Now, what is how they calculate? They calculate 2, 4, 8, 16. What do you get? 30. But here it is 33. So, how to be read is, as I showed you, the last bit ignore. It is always 0. Ignore. This one is 3. This is another 3. Okay. Now you know how to read this. Next is when there is a congestion. When there is a congestion, lot of data going and there is a congestion. There is some traffic with AF 41, some traffic with AF 31, some traffic with AF 21, some traffics are with AF 11. See, there's a heavy congestion now, based on the weight, it has to drop. Which one it will drop? This one, right? This is the one. 001, 100. Which one has got more weightage in CoS and ToS?
4.
4. Yeah. So this itself clearly shows that this gets dropped to avoid congestion, to reduce the congestion, because of that causes collision. To reduce that congestion, the one with the low weightage, the traffic with the low weightage will be dropped so that the others can freely move. Fine. Now let us go to the other scenario. Congestion is there again. Some traffics are marked with AF 43, some are marked with AF 41, some are marked with AF 33, some are marked with AF 31. Which one to drop in order to avoid congestion?
31.
You see here, this or same, correct? 4 4. This 3 3. Now if you see in this one, 3 has got low weightage than 4, correct? 3 has got low weightage, 4 is more preferred. Okay, now there's a tie between these two. Which one to drop? Should I drop 3 3 or 3 1? In this case it is 3 3. So if there is a tie in the first number, the second number, always biggest is low weightage. In the second number, it is opposite of what you did for first number. First number, what you said, bigger is high weightage, correct. But when you are focusing on the second number, big number has got high drop. You understand? 1 has got low, 3 has got high drop. You understood now how to read this chart?
Yeah.
Okay. This is very important place in DSCP. So when there is a heavy congestion, AF33 will be dropped to reduce the congestion. Still, if congestion continues, 3-1 also will get dropped so that 4-1 and 4-3 can move freely. Okay, fine then. Then what is left is we need to talk about a few more queuing methods like class-based weighted fair queue, low latency queue, and PQ. After that, we will have one lab and we will finish this topic QoS.